So hello and very good morning dear students. I hope you all are well. So today we are going to start the types of function exercise 1.3. In this functions, as I already told you that types of function are explained by me in class 11th ISC relation and function chapter. So from there you can have a better understanding of types of function, but let's have a quick recap of it. So in the course you have types of function. So here is the recap. Let's do a quick revision. I have taken the examples, I have not written the definition. Okay, if you can understand these examples and if you read the definition, you will surely get it. Okay, so starting with 1 function. First of all, this 1 function is also called the injective function. Now what does this say is that the function f from x to y is called 1 function if and only if the different elements of x has different images in y. What does this say? If you can see the all elements, all these 4 elements are having this 4 different elements are having 4 different images in y. So that is what this says 1 function. This is, they are doing 1 to 1. As we say, no, I want to do 1 to 1 with you. That means every 4 elements have 4 images in y. Now if you come to onto function, this is also called surjective function. Okay, so in this it says that every element in y. Now what I told in 1 that every element in x. Now I am saying every element in y has a different image in x. So can you differentiate between these two? They both are very opposite. We are saying they are having different image here, and here we are saying these 3 different elements are having image here. Or you can say that every image in this has a particular element here. So that is what we are going in inverse. We are going in revert. See, I used the word inverse. This is very important for you to understand, because the next chapter, whatever we are going to deal, depends on this only. Alright, that is inverse trigonometric functions. Because trigonometric functions are those functions which can be seen in this way, because those functions are 1 function also and they are onto function also. That is why their inverse exists. Okay, so that we will see in the chapter. Then into function. Now what do you mean by into function? Here can you see that all these 3 elements are having the 3 images in y, but this r is left behind. So what does this into function says? You can call a function from x to y into function if and only if at least one element in y is left behind, or one element in y has no image in x. Okay, like this. Now coming to the many-one function, by the name itself we can understand that if the 2 elements have the same image. You know what I told you, that no element can have 2 images, but 2 elements can have the same image, right? You can, like, that is what you make friendship with the one who have a like, if you both have the same nature, we say, no, birds of feather flocks together. So the same thing, 2 elements can have the same image. If such type of function exists, then we call that as many-one function. Then 1 correspondence. This is called bijective function, because it is injective also, surjective also. So injective, surjective, it combinedly can be understood as bijective function, because in this you can get both 1 and onto. So here, as you can see, this is also the example of 1 onto. This is also an example of 1 onto, and this is also, I wrote the example of 1 onto. Now can you tell me, this is along with many-one function, it is also one type of function. So this is one question for all of you to answer, that what will be the answer. This is one more kind of function, so that you need to answer. Now let's come to the more functions. Identity functions we have, constant functions we have, then one more Okay, let's see them. Okay, now let's see the identity function. Okay, so like identity function, how can we understand? For any x belonging to some set, that a set will be a non-empty set such that your function is belonging on that. So your fx, if it is equal to x, can you see that this x and this x should be same? Like say for example, I'm taking fx square, so the answer should be x square only. That means whatever I'm taking the element which is in some set, a non-empty set, then the answer, the result should be same whatever you took the element. Okay, so whatever the element has been taken, the same image that means the same element can be seen on the other side. So it says the identity function, because they create an identity. Okay, so like this we can understand. Then comes the constant function. By the name itself, can we understand the meaning of constant function? That means the function which is constant, or like which do not changes. So can we understand in such a way that fx can be any constant, or if I put here like a, so I may get any constant. Say for example b, where this a and b are belonging to some, like they are on the function like this, because this a is in this non-empty set, and this b, let us consider it is belonging to this set. Okay, so what did I say? That constant function, the value of the function should be the constant one. So that is called the constant one. Easy to understand. Then comes the equal function. What do you mean by equal function? Like say for example, I consider two functions f g, some f of x and some g of x. Then they are called the equal functions if their function is same. No, if the domain of f is equal to domain of g. Alright, so like there are two conditions. What are the two conditions as given in the book? The two functions f and g are said to be equal function if the domain of f is equal to domain of g, and the second one is f of x is equal to g of x. If these two conditions satisfy, we can call that particular function to be the equal functions. Equal functions because they are talking about two functions. Okay. Then zero function, can we understand by the name that if we are taking any non-empty subset and on solving we are getting its f of x is equal to 0. So for example x naught I am taking, can take x also. If the value of that particular function is 0, then we call that as zero function. I hope you understood this definitions. Okay, easy to, don't like they are not the toughest one. Only you need to remember the things. Okay, because the questions are not based on this. The questions are only based on whatever we studied just some minutes before. That is the types of functions, and we'll solve some questions on the basis of that only. Now comes the next one, that is monotonic function. So from this name, can we like figure it out two things? One is mono, which means one, and tonic means some tone, or like in some way. So one tone. So from here, how can we understand the monotonic function? The function which is neither increasing nor decreasing, doing nothing. So that is monotonic. It is in one tone. Okay, so that is why it is called a monotonic function. Now let me tell you, in the differentiation, in the application of derivatives, okay, this is a new term for you, but let me just tell you, we will understand how the function increases, decreases, strictly increases and strictly decreases. So there is some essences given in this monotonic functions, that function generally can either increase or decrease, or it can be strictly increase or it can strictly decrease. Okay, and if I say monotonic increasing function, that means in one tone it is increasing, and monotonic decreasing function, in one tone it is decreasing. So we will see the things more clearly in that particular chapter. Just keep in mind these things. Okay, now let's start with some questions now. Okay. Okay, so let's begin with the exercise 1.3 question number first. So we are given with a12, b36, and we are given with the two functions also. So they are fx is equal to 3x, and one gx is given to us, which is x square plus 2. We need to show f is equal to g. What do you mean by this? They both are equal function that we have to show. There is one set A in which there are two elements 1, 2, and set B which is having 3, 6. Okay, and the function is on A to B. Okay, how we will do this? So from this A we have to substitute the values in this, and if we get the values like this, like what they are trying to actually say that from A the elements will be chosen and their image will be seen as in the B set. Okay, that means this is A set and this is B set. 1, 2, 3, 6. So like this they are trying to ask. Okay, so let's do. On putting 1, so we are getting f1 is equal to 3. 3 ones are 3. And g1 we are getting 1 plus 2, which is what? 3 only. So 3 with 1 we are getting 3, and here also 1 we are getting 3. If you put 2, so you will get 6, and here also if you will put 2, so 2 square plus 2, which is 6. So 6 we got. So hence we can say f is equal to g. Like this you have to do. Then comes the next question. Check the injectivity and surjectivity of the following function. Injectivity and surjectivity means you have to check whether it is 1, 1 and on 2. Okay, so let's pick one question. Second one, f is under z. Okay, what do you mean by this z? This is the integers. Okay, all the positive integer, negative integer, 0, they are called integers. Fx is equal to x square. Now can you see that there are 3 questions where they are taking fx is equal to x square, but for natural number, integers and real numbers. Now what is the difference? Let's see. So here for 1, 1, yes. So let me just properly write that for 1, 1 and on to how we start and how we do the questions. Okay, so just see here. Let me rub this also here. So f is under the z integers, where fx is given to us x square. Okay, so for 1, 1, what we do, let us take the two elements. Let us consider x1 comma x2 which belongs to z, because the condition is given z. So we are taking x1 and x2 belongs to z. Now on putting into this function, we know fx is equal to fx1 is equal to fx2. Okay, so here our function is x square. So x1 square is equal to x2 square. This square will be cancelled. So here we will be having plus minus of x2. Okay, so here we have plus minus of x2. Now if I consider x1 equal to x2, then x1 minus x2 will also be there. Now what does this says? That x1 can have two images, right? Can we say in such a way that x1 can have, here x1 will be having two images, which is not the condition of 1, 1, because different elements have different image. If you can remember the definition, okay, this is the definition of many one. So you can surely say that this is a many one function. So here at last we have to mention that it is a many one function. You can mention, that's not an issue, but this is not a 1, 1 function. Now coming to the onto function, how do we find the onto function here? So always we consider for onto function, this is for 1 1. For onto, what we do, we considered our function y is equal fx is equal to y equal to fx equal to x square. So y is equal to x square. I told you in onto we go in reverse. So what you do, you go in reverse and find what is the value of x. So your x will be plus minus root of y. Are you getting this? Okay, so here x is equal to plus minus of y, and see, if you could prove that this is a many-one function, this already proves that it is neither 1 1 nor onto. So it's better not to go for the onto case, because we already have seen that this is a many-one function. So different elements in this x must have the different image in here. So it is not so many-one function. It does not satisfies 1 1 and onto functions definition. So here you can end up with your answer telling that it is neither 1 1 nor onto. Now if it is a case of what is the next question? If it is a case of let's take n, the natural number. So what here will be the things? If it is for the natural, yes, let me just again check. Yes. So for the natural number, what will be the case? So now our function will only accept the natural number. It will not accept the numbers which are not natural. So the case will be same. Here x1 is equal to plus minus of x. Now this condition won't be there. Here minus is there. Okay. So this condition we have to exclude. We got x1 equal to x2. So from here you can definitely say it is a 1 1 function. Okay. But on coming to the onto function, y is equal to x, you have to write that x1 is not equal to minus of x2. It is an inadmissible case because we are dealing with the natural numbers. Now for onto case, y is equal to x square, x is equal to plus minus of root y, as if ever you put y is equal to 2, you will get 1.4414, which is not a natural number. Okay, so here you have to say it is not satisfying the onto function's definition. So this is not an onto function. So this is 1 1 but not onto. So likewise you have to go. Okay, I hope you understand. Let's do some more questions. Okay, so let me just dive you through some of the common things which you have to keep in mind to solve this exercise very smoothly. Okay, so because there is the same way for doing each and every questions, but in this chapter you need to remember very small things, like in 11th class whatever we have studied about the range and domain of the trigonometric functions, that you have to remember, and what are the types of functions. Okay, we'll understand the day by day or exercise by exercise. We'll be adding new things in our mind. Okay, so you need to keep all those in your mind, because this will surely help you in the further chapters. Okay, so let's see here. I've taken fx is equal to x. Now you would be thinking what type of this sign is. So this is a modulus function, or sometimes called the mod function. Now in the lower classes you might have seen that this, if you have -2 in mod, so it comes out with a positive value 2, and if it is positive then this will be positive only. Okay, so the same, what we can say, we can think of the same here, modulus of x, where x is belonging to the real numbers. Okay, this r is a real number, and function is also in the r. The domain and the range, they both are in the r. So this modulus function is actually gives two values, that is the positive value and the negative value. Okay, so the modulus function gives two types of value, that is what I said, the positive value and the negative value. So whenever if I'm putting 1 here, so it can give me two values, 1 or -1. Okay, or if I take here minus, so plus minus, vice versa. So here what we say that if you want to prove, no, now I am asking you that what type of function this will be. Will it be a 1 function, onto function, or it would be a many-one function? So how we can understand, if I take 1 here, so 1 and -1 will belongs to this value x. Okay, so if I'm putting 1 here, I am getting two values, positive 1 and negative 1. Are you trying to understand this with the mapping? That if I put 1, I'm getting two answers because this is a modulus function. So it has some type of function, or we can say it has some type of working, a mechanism. Okay, so it gives two. So one element is giving two different images, which is not acceptable for the 1 case and onto case. So hence we say this is neither 1 nor onto, but yes, it is definitely a many-one function. Okay, now like say for example, if we take a question from the book, like I'm remembering one of the questions, sine square x plus cos square x, and x is belonging in the real number. Now from here you can one thing is clicking here, sine square x plus cos square x is 1. So now how we will prove that this function is neither 1 nor onto? Let's see how. Your x should be a real number, so let's take x as 0. If I take x as 0 and if I put here sine square 0 plus cos square 0, what I am getting answer? 1. So 1. Alright. If I am putting x is equal to pi by 2, so sine square pi by 2 plus cos square pi by 2 is what? Again 1. So pi by 2 is also giving 1. If I put pi, this will also give 1. If I put any number from this real number, I am getting the same answer 1, which is violating the definition of 1 and onto. Hence we say that this is a many-one function and not 1 onto function. I hope the things are getting into your mind, and I can see that this exercise seems to be the objective exercise where you can do. There's not much writing in this exercise. Okay, you can take the help of examples how to present the solution. Okay, you're in the 12th class and I feel that you are mature enough that I should not tell you how to write or how to solve the things. Okay, just take the help from the examples and try to do the questions. Okay, now we'll come up with more questions in the next video, and we'll start with the next topic, that is composition of functions. Okay, so I expect your utter sincereness and importance to this chapter, as I already told you that this is the mother of some chapters which I will tell you later. Okay, so hope you'll study and do the homework. Okay, so take care, bye bye, thank you so much, have a nice day.